Very good morning to all of you. As we have discussed the topic that is named as electromagnetic waves in the previous class. So today we are going to discuss the further topic of that chapter, that is your transverse nature of EM waves. As I said you already that there are two kinds of wave. One is longitudinal and another one is your transverse. So longitudinal is the wave in which direction of propagation of the particle and the wave is going to be in the same direction. If there is opposite direction, that means definitely it is a transverse nature. Or one will also say like this, that in which the particle travel parallelly, that is going to be longitudinal, and when in which the particle oscillate perpendicularly, it is termed as transverse. So today we are going to discuss about the transverse nature of electromagnetic wave. What is our aim? Our aim is to tell that we have to prove you that the component along the direction of propagation of wave is going to be zero. As we have discussed yesterday that it is the x direction is the direction of propagation of wave. The direction of electric field is always along y-axis and the magnetic field is going to be along z-axis, right? Now what we are going to do is that the direction of propagation of the wave, okay, is always going to be zero. That is what we have to going to prove in the case of transverse nature of electromagnetic waves. So here let us consider a plane wave. Okay, this is your coordinate axis, this is x-axis, this is y-axis, and obviously this is z-axis. Okay, now what you are going to do is you have considered the plane wave. Okay, so plane wave is always going to make the plane wave front. Wave front is nothing but it is a kind of disturbance. Okay, so here wave is propagating along x-axis. As we know, in the case of electromagnetic wave is always propagating along x-axis. Okay, so when it is going to propagate, let us say that it made a wave front, that is your EF, like this. Okay, this is your E, this is your F, and this is your G, and this is your H. This is a kind of wave front, you can say, that a wave is traveling. Initially when it is not going to travel, it is going to make the wave front like this. Now let's say at any time t, it reaches somewhere to this point. Okay, if it is reaches to this point, then again it is going to make a wave front. Okay, so here it is going to make a wave front again in this direction. Okay, so let's say how it is going to make. Okay, it is going to make like this. This is your wave front here. Okay, you can see here, you can either go like this also. Okay, this is your another kind of the wave front. This wave front is made at the time t, you can say like this. Okay, so basically we have to complete this figure. So here we have only two wave front. At time t is equals to 0, the wave front is EFGH, and at time t the wave front is going to be A, B, C, D. Now this is the wave front at time t. Okay, now what you have to remember is that this wave front is going to depend on the two factors. At first of all, the direction of propagation of wave, and another one is the time. Okay, so left of the wavefront ABCD depends on two factor. What that two factor is? That is x and t. X is the position and t is the time, but not on electric or magnetic field. You have to remember this thing. Okay, that they are not going to depend on the electric or magnetic field. They are depend on the two factor, that is your position as well as your time. Okay, now the thing is this, why it is going to be depend on only these two factor and not on electric field and magnetic field? Because we have considered a plane wave. Okay, the reason behind this is that we have considered the plane wave, and plane wave will never depends on the field, so that's why. Okay, now at time t, okay, now the left of the ABCD means left, that side. Okay, that depends on position as well as time, and the right of the ABCD, that is going to depend on which factors? That depends on, only depend on the position. Okay, so that means if I apply Gauss law here, now using Gauss law. Now what does the Gauss law state? Gauss law state that total flux in this case is going to be 0. Why? Because it don't enclose any charge. You know very well that for applying Gauss law, the charge should be there, but as in this case there is no charge, so that's why the Gauss total flux is going to be 0. That means E dot ds is going to be 0. Okay, and what are the phases? That is your ABCD, and this is your EFGH. Total is this much. Now we are going to write in the forms like this one and this one wavefront. Okay, bottom and the upper one, back and the front. Okay, so that's why we will write here ABCD. So that is your B E dot ds, right? And in the similar manner, as the corresponding for this ABCD is EFGH, so that's why you have to write it here EFGH E dot ds. One phase is going to be completed. In the similar manner, other phases will also be right, like ABFE, that is your E dot ds. Okay, and in the similar manner DCGH E dot ds. These are the phases of the cube, nothing. Okay, and here it is front AEHD, that is E dot ds, and the back portion, that is your BFGC. Okay, so that is your E dot ds, right? So this is your equation number 1. Okay, now you can see, you know very well that electric field depends only along the, in which factors? Only along x-axis. Okay, E is not going to depend on, does not depend on, you can say like this, that electric field is not going to depend on which factor, because the wavefront is only on the case that is EFGH and ABCD, right? So it is not going to depend on y or z axis. So the contribution of the flux coming from the phase normal to y or z axis cancel out each other in pair. For example, if the flux is going like this, this is also going to like this. So these are at the angle of 90 degrees, so that's why they are going to be cancelled. Okay, in the similar manner for front and backward, the same process is there. But for the case in which the wavefront is like this, in this case it is not going to be cancelled. Okay, so here I am saying that for this phase as well as for this phase, this flux is going to be 0. That means AEHD E dot ds plus BFGC E dot ds, that is going to be 0. Why it is going to be 0? Because it is not going to depend on these axes, so that's why. Okay, this is your ABFE E dot ds plus DCGH, and this is your front and backward phase, so that's why it is also going to be 0. Okay, you have to use this thing in equation number 1. When you are going to use these, or these two values going to be cancelled. So what do you just remain with? You just remain with this. Okay, so here you will remain with ABCD E dot ds plus EFGH, and this is your E dot ds. This phase will be there because these are going to be put the value of 0, so that's why they are going to be cancelled. Okay, now what we are going to take, we are going to solve one of these, and we just going to put the value here. So let's say how. Okay, so here when we are going to write, like first phase we can take ABCD. Okay, that is E dot ds. Okay, because the component is also along the x-axis, so that's why we will write EX ds cos of 0 degree. Why 0? Because the direction of the propagation of the wave as well as here you are seeing the Ex. Okay, so here you can see like this, so that's why, because the same direction is there, no? So Ex is going to be taken as constant, so taken as outside. This is your ds. Okay, cos 0 is 1, so that's why no need to write. And this is your, similarly we will write it as Ex, and this is your surface area of the cube. Okay, similarly in this case the electric field will also act in this wave front, but its direction will be opposite, like this. Its value will differ in the direction opposite, so that's why Ex dash. Okay, the similar process is going to be there. So here when you are going to write, it is Ef Gh, and this is your Ex dash ds. And because the direction is negative, so that's why we will write minus Ex. Okay, and that is your x. Okay, because Ex is anti-parallel to the surface, so that's why. Okay, so we just put these two values in the previous equation. So we have Ex s minus Ex dash s is equals to 0. That means we have like this, s and s is going to be same, so that's why it is going to get cancelled. That means the electric field is going to have the same component, or you can say that x component of electric field does not change with time. Okay, or electric field along x axis is going to be static. ठीक है, एंड स्टैटिक फील्ड कभी भी वेव प्रोड्यूस नहीं कर सकता भाई. ये यहाँ से क्या पता चलता है कि इलेक्ट्रिक फील्ड इज गोइंग टू बी स्टैटिक. ओके, एंड स्टैटिक चार्ज इज नॉट गोइंग टू प्रोड्यूस अ वेव. ओके, तो ये तो सारा ही कैंसिल हो गया इसका मतलब. ठीक है, अगर ये वेव नहीं प्रोड्यूस कर सकता, दैट मीन्स Ex डैश इज इक्वल्स टू Ex इज इक्वल्स टू 0. तो यानी फिर ये 0 है. ठीक है, दैट मीन्स इलेक्ट्रिक फील्ड इज पैरेलल टू द डायरेक्शन ऑफ प्रोपगेशन ऑफ वेव. डायरेक्शन ऑफ प्रोपगेशन ऑफ वेव. ओके, तो यहाँ पे हम बोल रहे हैं अगर इलेक्ट्रिक फील्ड पैरेलल होगी डायरेक्शन ऑफ प्रोपगेशन ऑफ वेव की, तो उसकी वैल्यू कितनी होनी चाहिए? 0. अगर 0 है दैट मीन्स अगर वो पैरेलल नहीं है तो फिर कैसी होगी? ऑब्वियसली वो कैसी होगी? फिर परपेंडिकुलर. वी हैव ओनली टू केसेस, आइदर द वेव कैन ट्रैवल पैरेलली और आइदर इट कैन ट्रैवल perpendicularly. So that is how we can prove that it is having the transverse nature. Transverse nature means the field is one of the field. If we are going to prove that one of the field is not going to travel parallelly, that means it is having transverse nature. Otherwise it is having longitudinal relation, right? So this is your first topic, that is your transverse nature of EM waves. Okay. Okay, next is your relation between amplitude of oscillating electric and magnetic field. Okay, next topic is relation between amplitude of oscillating electric or magnetic fields. Okay, we know that in order to write the magnitude of the electric field, that is equals to E naught sine kx minus omega t. Now this is what we have studied in the previous class. Okay, similarly we can write the B is equals to B naught sine kx minus omega t, where E naught or B naught are the amplitudes of the wave. And in the previous class I told you that k is the propagation constant and its value is equals to k is equals to 2 pi by lambda. So we will differentiate it with respect to x. One of the equation, let's say the first one, this one. Okay, you just differentiate it with respect to x. So this is your curly E upon curly x is equals to E naught. साइन की डिफ्रेंसिएशन क्या होती थी? cos. ठीक है, cos kx माइनस ओमेगा टी, और बिकॉज इट इज डिफ्रेंशिएटिंग अलॉन्ग x, सो x फैक्टर जिसके पास भी है उसकी डिफ्रेंशिएशन भी होगी, सो दैट्स व्हाई यू विल हैव k ऑल्सो, राइट? सो दिस इज द इक्वेशन व्हेन यू हैव सॉल्व. सिमिलरली इक्वेशन 2 is differentiate with respect to time. Now this one equation, okay, this one, equation 2. Okay, so here it is curly b upon curly t. So that is equals to b naught cos kx minus omega t, and this is your minus of omega. Okay, and because it is minus, so here minus sign is there, minus minus is going to be plus. So this is your b naught omega cos kx minus omega t. Okay, now what you are going to do is you have to put the values, because the field are going to be same. E is equals to B in the case of electromagnetic wave. So this is equals to E naught k cos kx minus omega t, and this one is equals to B naught omega cos kx minus omega t, right? So this one will be going to cancel because these are the same. Okay, so in order to calculate E naught, that will be equals to B naught omega upon k. ठीक है, since you know that omega upon k is equals to ओमेगा की वैल्यू क्या होती है, that is 2 पाई बाई टी. तो 2 पाई बाई टी को कैसे लिख सकते हैं, न्यू लिख सकते हैं ना, 2 पाई बाई टी. 1 अपॉन टी क्या होता है, फ्रीक्वेंसी, तो 2 पाई न्यू भी लिख सकते हैं. सो के क्या था, दैट इज 2 पाई बाय लेमडा. दिस इज गोइंग टू बी कैंसल्ड. ओके, सो ओमेगा अपॉन के की वैल्यू क्या आ गई, न्यू लेमडा. ओके, बट इन द केस वी नो दैट न्यू लेमडा इज ऑल्सो इक्वल्स टू सी, ये भी तो होता है. सो हेयर वी आर गोइंग टू रिप्लेस दिस बाय ई नॉट इज इक्वल्स टू न्यू लेमडा भरना था हमने यहाँ पे, ठीक है, ये आना था बी नॉट इज इक्वल्स टू न्यू लेमडा, बट न्यू लेमडा किसके इक्वल है, सी के. सो ई नॉट इज इक्वल्स टू बी नॉट सी. ओके, तो यहाँ से सी निकल जाएगा, सी विल बी इक्वल्स टू ई नॉट अपॉन बी नॉट. दैट मीन्स रेशियो ऑफ द एम्पलीट्यूड ऑफ द इलेक्ट्रिक एज वेल एज द मैग्नेटिक फील्ड. ओके, हाँ, इन वैक्यूम, if we are going to talk about the vacuum, what is its value? Its value is C is equals to 1 upon under root mu naught over E naught. This is the value, right? So this is what we are starting. Okay, so as I told you earlier also that electromagnetic waves are always traveling in the speed of light, and their electric or magnetic field amplitude is the ratio for the speed of light. Okay, so this is for your relation between the electric and the magnetic field. Clear? Next is your energy, density, intensity and momentum of EM's waves. तीन चीज़ें निकालनी है, एनर्जी डेंसिटी निकालना है, इंटेंसिटी निकालना है, मोमेंटम निकालना है. ये चीज़ें हमने निकालनी है. सो दिस इज़ व्हाट वी आर गोइंग टू स्टडी इन द नेक्स्ट क्लास. फॉर टुडे it's over. Thank you and have a nice day.